Yeah, I hope you had a good time so far at the ADC. As has just been said, we're talking about unit testing. Yeah, off we go. So, who am I? I've studied at the Technical University in Berlin, uh, worked amongst other companies for Z-plane development as an intern, then worked for many DSP-related companies in Germany, the Netherlands, and the UK. And I'm now working for Spitfire Audio and have been involved with labs and the CI/CD pipeline. And guess what? Unit testing. Over to Dino.
Hello, everyone. I'm Dino. Studied at Bournemouth University, and then there was a work placement there, and worked at Rebel Technology, building their really cool programmable guitar pedal and some modular stuff. Yeah, that was a great time. Then went to Queen Mary, studied sound and music computing. Shout out to the Bella team, yeah, that was really cool. Did a lot of stuff with that, and then interned as a DSP intern at Acoustics for a time, and then for the last sort of 7,000 years, I've been at Spitfire, working on such hits as Labs, BBC Symphony Orchestra, the Air Convolution Reverb, and some internal DSP gubbins. So what's to come? We're going to be testing. We're going to be writing tests in Juice for an audio plugin. So we'll talk a little bit about that. We'll talk a little bit about unit testing in general. There's going to be a demo, which is coding live, which is with some corners cutting, but it's exciting. Other testing we'll talk about, and then some further reading. There is a QR code, scan it. So testing audio in Juice. What are we going to be doing in our demo? Or what are we using in our demo? We're going to be using VS Code. We're trying to keep it as sort of like accessible for everyone who can access it. So VS Code, Juice, there's a CMake project. We're using Catch 2. This will be all on a repo that Marcel will be putting up. And so in our demo, we're going to be making panning for the audio heads and the professionals. There are lots of different ways of panning. We're not going to be going into like pan law and all that sort of stuff. This is not a talk on panning. This is a talk on testing. So don't at me in the Discord. In linear panning, so just simply the output channel is going to be just a scale of the input channel based on the pan value. If it's a mono input, we're just going to like double that for both channels. That's just, this is just, it's more of a disclaimer than anything. So yeah, but a small thing on floating point comparison, we're not going to be doing equals, just because, if you're comparing float values, there's the precision thing. And so, and rounding errors. So here what we do is we get the absolute difference, and then the difference of that should be smaller than this given epsilon value. Read into it. It's great. So unit testing.
Yeah. So to talk about unit testing in more general terms, let's first start with what is a unit. Basically, the idea is it's whatever you have as the smallest possibly testable bit of code. Can be a function, such as the update function. Can be two functions. If you have a read, you might also have a write function, and you might want to test them together. All this could be wrapped in a class. Then maybe the class is what you consider your unit. And it could go as far as a module, but then you get into the territory of integrated testing maybe, which is another thing, to cut it a bit short there, to stick with the unit testing. You might have seen these abbreviations, TDD, BDD. What does that mean? Well, TDD stands for test-driven development and goes by the idea of you write first your test and then you write your code. We we're planning to demonstrate that in a moment. And then, what's BDD then? That's behavior-driven development. And let's try to emphasize that you actually explain what the hell you're testing. So when test-driven development came around, test might have been labeled test adding positive numbers, test adding negative numbers, and so on. That's all very plain and clear if we're talking about adding numbers, but if you have your own bespoke code, it might not be so clear what the hell you are testing, and you might find your own test code a half year later and scratch your head what you've been testing there. So you try to be more descriptive, such as you write when A is 1 and B is 1, then the result is 2. And by doing so, you have a clear idea of what that test is showing you and what kind of behavior you expect from your function. Another way to put this into words is that you have a scenario and you have a given and a then, but it all has the same concept behind it, as I just explained. Now, as we said, we are lazy people, and the great thing about this approach is the lazier you are, the better it will work. So you start off with writing your first test, and you try not to be very clever. You just think of whatever shows in the quickest way possible that you as a developer have not done the job. At times that can be just calling the function and somehow you crash already. And that might be your first test. Then you move over and put your developer hat on. And then equally, rather than doing a full-blown implementation, you just do whatever is the quickest to get around passing that test. Then once the test is passing, you might reconsider refactoring your code a little bit. And then you pass the baton back to the tester. Now that the test is passing, the tester might consider refactoring the outline of the test, and then move on and write another test that is maybe that tiny bit more clever than the test that has just been written just before. And you keep going around in that loop until you got so many tests that the developer is forced into writing actual working code. So there is this idea that this whole unit testing stuff is just taking up too much time, and if you want to have a quick turnaround, it's just that extra time you don't want to waste. You want to quickly get your code to work and so on. But matter of fact is, if you don't test, then you find yourself debugging later. And that can be a heck of a lot more time consuming than the unit testing, because you always got to compile your complete code base, fire up the application, click your way through to your new feature, hopefully hit the breakpoint, hit the wrong function key, miss the breakpoint, do it all over again. And it's just tedious. And if you do this unit testing, then there's a heck of a lot less of that. If you do find bugs in your code, you can assume they are at the integrational level, because you've covered the unit level. So if there is a bug, it's also much quicker to find. And with the unit testing also, you go function by function. If you've already built your new feature for a whole week or so, and then something is wrong, then you got this whole code from the whole week for every day, like where did I go wrong? Whereas with the unit testing, you're always just busy with that bit of code that you're currently working on. And there's no guessing where things have gone wrong. You are busy with what you're busy with. So then rule number 1, in terms of going about the testing, thou shalt not rewrite the code you're testing, just briefly. So a more in-depth detail about, let's get rid of this quickly, the basic concept and how to structure your tests. Starting at the top, in your test, you outline what you're testing. You have certain inputs. And then you, from those inputs, you have certain expectations about the output of your function. At the bottom, you see an example going again by this very simple adding numbers example. You may have A1, B1, and then obviously with adding, you expect that to be 2. You might have, or are very likely to have, some sort of preparing stage as an idea here to go with that example. You set your maths operation to add, and then you go about calling your function. So that could be labeled exercise, and yeah, if you have a class, create the class, call the function, and see what you get back. And then eventually, you want to evaluate the results and see if that matches up with your expectations. And there you have the full-blown different stages of a unit test. So here we go. We are planning to demo that to you now, and thereby slip into our alter egos as lazy developer and lazy tester.
Righty, just to say this fit me a lot better this particular year. I didn't have a job then, and now I do. And sorry, go on.
Lazy. Lazy. Yeah. I was going to beat my high score in Super Mario Kart today. But then I was given this job here to test this code. But I have my assumptions. My developer colleague, I happen to know, is pretty much as lazy as myself. So I bet I don't need to do much to see that things are not working. So here in front of you, you see I've already set up a test file. It has basically the same name as the class file, so to say, of the implementation, which is plugin processor for our case. So there you go, plugin processor test. You start off with whatever test framework you have, write the skeleton of a test using catch2. In our case, that's test case. And then at the front, you can specify in a string, you can specify a bit what you're going to test. And then as a second string, you can also organize your tests in groups. And we usually use the test class as our group. And then you throw in a require false, which means this test should fail. So let's try and see. Indeed, we have a failing test. For the moment, I don't need a developer to do anything. So now we want to integrate what we actually want to test. And since we're testing audio, we are going to try and call the process block function of the audio plugin audio processor. I was going to make this a bit bigger so everyone can see. There you go. So if I then go audio, got some clever snippets here. So then you see everything's here. Let me close this for the moment. We're creating our object. There's lots of red now. If I get this header included, that should go away. There you go. So you see we're creating the an instance. We're calling the function. Obviously, we need to throw in the input. So we define some inputs up here. So this test is actually not testing anything as it is, but it should pass now. And indeed it does. But that already can also go wrong for whatever reason. You might need to do some more initialization steps for your class. But yeah, we got lucky, this works. Now, to test anything, we obviously need to do something with the inputs. So if I do some preparation, that would be passing in input values into the buffer. So we have the buffer down there now. Can get rid of it here. Define an input value. And let that be a whole lot of ones. I can explain a bit more about that in a second. Then I made a few constants using my initials as the namespace. Let's get those in. And there you go. There's some code that's happy. So to explain this in a little more detail, we are now in unit testing world. We're not running an application. If we were running an application, I would never have a buffer with just 8 samples. But for testing, that's just fine. Could even go down to 2. Maybe this is already over-engineered for tests, to be honest. Input value, just fill the buffer with a whole lot of ones. Would never do that in the real world unless you want to kill your speakers. But again, for testing, that's just fine. Those are all benefits you get from going about it in this particular way. Right, now we have a buffer where we know what's in there. So we can then, after having run the function, evaluate that buffer. We talked earlier about comparison. We're using that particular approach, but we've put that in another header. So let's get the header in. And now we have some expected values for the left and right channel. And since we're doing nothing so far, I just say, how was it? Oh yeah, expected L. And expected R. Right. So again, when I run this, because we're just passing through the audio as it is, that's all correct. Now, let's finally get to our panning. If I remove this and replace it with another snippet here, this I don't need here. So now we're calling a set pan function, which doesn't seem to exist due to our lazy developer. As we said, we want to test something very simple. So the simplest I could think of for now is panning all the way to the left. In other words, set the pan to 0. Then my expected left value should be 1, just like the input value. And for the right buffer, it should go down to 0. So now I can't even run anything because my lazy colleague hasn't even given me a set pan function. So over to him, and I can get back to my Super Mario Kart game.
The reality is, real life, I don't have time to do any of this stuff. The executive committee have tasked me with making an 808 kick drum subscription service, and I have 2 weeks to implement it without any technology. So I'm going to do the absolute minimum to get this to compile and also build. And also pass the tests. So we also have snippets. So I'm just going to make a function. So that should hopefully then build. I'm not even going to set it to do anything. I'm just going to put that in. And then because this is a live coding demo in front of people, I'm just going to copy and paste stuff. Just copy that in there. And so then he wants so I'm just going to get these right pointers here. That there. And so he wants the right output to be 0. So I'm literally just going to copy this, paste that, index, set that to be 0, right? And hopefully that'll just pass his tests. And then wait for it to build, pass the test. Now I can get back and do real work. That's it.
Ah, dear. I was just in the middle of my solitaire. Now I'm back to this again. Okay. Well, looks like he mastered this, but I'm sure, lazy as he is, hasn't really done a thing. So I need another test. And since that's so, I will now replace this bit with something I would call outline. I explain in a moment. And then have my first section. And then have another section. And then see how that will go. But to explain, up here, we just show this is our inputs, and that's our expected outputs. And now with the sections, if I wasn't going to work with sections, I would have put text like this here at the top with the test case. But since we're going through different scenarios within this test case, we're using these sections. What you need to know, this is specific to catch 2. And what happens is with every section you write, the code gets executed from the top, enters one of the sections, comes out of it, skips all other sections, goes about the rest of the code. And then if you have another section, it goes back to the top, skips the section it has just done, enters the next section, and executes all of the code then in accordance to what you put in the other section. So What we have here for our sections is one section saying when pan is 0, then L is equal to input, R is 0. And now I made another section when pan is 1, then L is 0 and R is equal to input. So I'm getting a bit ahead of myself. I'm going to comment this out for the moment. This would be the refactoring. I've not changed anything other than adding the section in. It's the same test as we've seen before. This should go green. And it does. And now I bet you my lazy colleague has not covered this. And I can go back to play a bit of Donkey Kong. Over to you.
Okay. Like I said, I don't have time. The executive committee have tasked me with making a white noise NFT library. I have the end of the week to do it. So as per last time, I'm going to do the absolute minimum to do this and copy and paste accordingly. So, okay, so he actually wants me to use the pan now. So I'm not that bothered. I bet he's not even done that much in terms of testing. So I'm just going to create a pan variable. And I'm going to initialize it to 0 just because, you know, I'm a professional. So new pan equals that. Great. So then in our processor, then what I'll probably do is actually a bit more copying and pasting because, you know, that's what we all do. I copied and pasted that one. I'll copy and paste this one. Fantastic. So compare. And so then here, what I'll do is I'll go if MCR compare equal float. So if that pan value is equal to 0, so I'm normally used to Vim because I'm a professional, so I don't, you know, this is a bit slower, you know, kind of dumbing down. So put that in there, right? And then, so when pan is equal to 0, I will do what I do before. But here, copy paste that, right? Put that in there. Formatting. I'll get the left channel because I'm assuming, you know, that's what he wants. Does that pass the test? It does. Fantastic. I can do real work now. See you later. Thank you. Cheers.
Thanks.
Buy me a drink later.
I'm not sure that deserves any applause. Okay, so I bet you this lazy man hasn't done a thing. So I'm just gonna come around with another test. And this time, I'm just gonna set the pan in the middle, stick to my ones in the input buffer, and expect 0.5 on the left and on the right hand side. And lazy as my colleague is, it's fading. And I can get back to my Prince of Persia game and leave it to him.
All right. I don't have time for this. I'm in the middle of making a blockchain-based granular synthesizer. So fine. Bare minimum. He wants that. Fine. You know what? I'm gonna copy and paste again. Right. I'll put else over here. Right. Oops. And then I'll go, if that's 0.5, then I'll set both of these to be 0.5. Fantastic. Oh, I'm so good. So good at what we do. Is that gonna pass? That's right. Thank you. I can go back to real work now. Cool.
This is getting silly. Oh, well. I'm not going to continue with changing the pan value. It seems I need to get a little more clever. And what I'm going to do now is I change my buffer and go with 0.5 values. That should get him. I need to have these guys as well. And this section still holds, but I should add with 0.5 as input samples. Cool. Why am I not surprised? Back to my gaming.
So I actually got a call from like Google and the US government, and they told me to rewrite all my previous work in Rust instead of C++. And actually, I think I've got AI as well, so that'll actually be actually quite easy. So I've got actually a fair amount of time. So, you know, thinking about it, looking at this stuff, I mean, I could obviously go through and I could probably, instead of, assigning the actual value, I could scale it, because I think that's probably more, the kind of a better way to do it. But actually, thinking about it now, I've had a few pints and now I'm thinking more clearly. So actually, I could probably just go here, get these two, do that. Right, times it, like I say, here. And then these are actually just the pan value, I realized. So if I just, oh God, if I just delete that, right, formatting, because we're professionals. And then, so I set that to pan, right? And then I set to 1 minus pan, right? That should hopefully pass. Great, fantastic, that's it, we're professionals. But actually, I think I have a bit more time because, AI. So I'm going to refactor because nothing ever wrong comes with refactoring. It doesn't introduce bugs or anything. So I've been reading the Juice forums, like, all good professionals. And I realized that I've been reading about this apply gain stuff. So I'm going to do that. So apply gain, right? So that's, not apply gain. And I'm going to let it do it all for me. Fantastic, yes. We didn't do that, that's exciting. Well, whatever. So channel 0, channel 1, start sample 0, right? And then buffer dots, come on, get number samples, fantastic. And then I'm gonna, so that's for the left channel. So yep, that will be pan -1, fantastic. And then get rid of that, copy and paste because we're professionals. And then for the right channel, do that, right? That's just gonna work, which is great, because, I know what I'm doing. I'm a really good programmer. ChatGPT told me. So set that to pan as well. Great. So that's just gonna pass. Fantastic. On the pints. What have I done? God, the tests are telling me I've done something wrong. What have I done? Oh, hang on. Oh, I think I did that wrong. Surely not. Gosh darn it, the tests have saved me. Thanks, guys. Thanks. Back to it.
Right. So that was our little demo. I hope you enjoyed that. We're now going to talk a bit about other aspects of testing, other ways of testing. But rest assured, we can talk more about what we've just done and so on once we're done with a few more slides. So one thing that we came across when setting up this talk is property testing. And for some people, that's the new kid on the block. For others, it's maybe already an old hat. I don't know. But the way that works is vaguely similar to what you just saw. But rather than having all these different test cases that we just went through, you just have a good think about what will always be true for the final results, no matter what your input is. And then you can apply random samples, in our case, random pan values. And for example, you can make a check, and if the random pan value you find is below 0.5, you should expect that the left channel, if it was a mono signal, is louder than the right channel. And the left channel should also be louder than half of the initial mono signal, if you remember from the graphs we had and so on. So that would be properties of your pan function. And thereby that's conditions that are always met. There's test frameworks for this. I was going to mention that here. I realized that fell through, but I think there's something called rapid check for C++. I haven't tried it out, but from what I know about these frameworks, they also get clever about the random values. So they don't run tests forever. They start finding the corner cases and so on, and then have a small sample set in the broadest sense of the word sample to run these tests. Then a bit more explanation about test types. What we've been talking about today, that's unit tests. There's something called integrated tests. That is, if you test at a higher level and you don't do mocking, which is something we're going to get to in a sec. And you're not just testing your class, but you test all the so-called collaborators that sit below in one washing up, so to say. Such tests can be helpful for development, but you'll find people suggesting not to maintain them because it's really tedious to maintain. It tends to be tedious to maintain integrated tests. Last but not least, end-to-end tests. That is where you actually interact with the UI of your application with something I would call a puppet that clicks on buttons, and then you'll find yourself on a different screen, and maybe you take a screenshot and cross-compare if you find the same screenshot in your automated test after clicking the button and so on. Focusrite have made a great framework for that, Juice end-to-end, it's called. Then you may also want to not be too specific about the test types. And I've heard Google, they just talk about small, medium, and large tests. That's also a way to obviously to categorize tests. Mind you, unit tests are not performance tests. They, as you've seen, they give you the opportunity eventually to throw away all your code and replace it with something that's maybe more performing, but the tests themselves won't tell you how it's more performing or not. You would keep that separate because you want your unit tests to run quickly, and for performance tests, those things are a bit more involved. You will want to have some sort of stopwatch. you will be wanting to do warm-ups when you run through the tests. And you need to consider on different hardware and on different operating systems, you'll have different outcomes. So it's much harder to set criteria. Similar things go for resource testing, and we're mainly concerned with automated testing, but of course there's also manual testing, not to forget, and that's still always good to have, I would say. So that's about test types. Then briefly mentioned mocking. That would be a whole 1 hour talk on its own. I've touched on collaborators. If you think of your great Grand Theft Auto new game, and you have your virtual car in there, and it can be running with different engines or one particular engine, whatever. You'd be wanting to test your car code, but you don't want to dig into what the engine does. In fact, you might have scenarios where in the game there is moments where the engine might break down, but you need to drive the car for so long for that to happen. You can mock that with a mock engine. You can have the running, well-running engine, test your car code to be acting upon that properly running engine in one case, and in another case you mock your engine to have a breakdown, and then see that the code that is in the car class acts accordingly. So again, that would still be unit testing, because then your unit is the car, it's not the engine, and thereby you need some mocking framework that can help you with that. You work with what's called dependency injection. You put the engine in the car, so to say. You pass an instance of an engine to your car constructor in programming terms. And the engine would be a collaborator. Other things could be your file system. If the file system doesn't have a base class where you could then derive a mock version from it, you might need to write a wrapper around it. Those are all helpful things to go about your unit testing. But yeah, a whole other world we can't get into for today. Then a quick word on Kent Beck. He's somewhat, I would say, said to be the godfather of unit testing, although from what I've seen on Wikipedia, there's been people before him doing this stuff. He is the inventor of extreme programming, a term that he doesn't like anymore from what I've heard, because it's drawn the wrong crowd. And all this is part of the agile development, and there's a group for that, and he's been one of the founders. So all of this goes with all these other agile development concepts that you might have heard of. This is just one of them. And then in terms of further reading, we put the same links here on that GitHub repository that's mentioned there, and the QR code takes you straight there. There's a link to our LinkedIn pages. If you are more interested in the property testing, you find a link to a video there. There is a link to the Catch-2 framework, the Juice end-to-end framework, link to a page for this book that has helped me a great deal in understanding all this stuff, and in particular for people that do embedded, that might be interesting. Embedded developers tend to think, oh, this is some crazy Java, Python stuff. We can't do that in embedded, but not so. You can very, very well write unit tests for your embedded framework. And yeah, also a link to Kent Beck. And there you go. That leaves us with questions and further thoughts.